Welcome back to the channel. Today, we're diving into a fascinating chapter about how science decides what's real and how a powerful method called meta-analysis can reveal truths that single experiments often miss. Let's break it down in a simple and understandable way. Main summary. Meta-analysis is a technique that combines results from many independent studies. It's built on one key idea. Replication is the heart of science. A single experiment might give an interesting result, but we only trust it after repeated tests. To explain this, the chapter uses sports. We know Mickey Mantle was a great player not from one game, but from thousands of attempts. Similarly, if someone watched only a few games where Clyde Drexler outscored Michael Jordan, they might wrongly conclude Drexler was better. But when we look at all games together, Jordan is clearly superior. This is exactly what meta-analysis does for scientific research. Instead of focusing on one experiment, it looks at the entire collection of evidence and finds the true pattern. Why meta-analysis is so important? Traditional reviews often rely on a few chosen studies. Meta-analysis is different. It examines every available experiment, codes them systematically, and produces one clear statistical conclusion. Modern sciences, psychology, medicine, and social sciences depend on meta-analysis because individual studies often produce mixed results. The aspirin example. A famous meta-analysis looked at 25 studies about whether aspirin reduces heart attacks. Individually, 20 out of the 25 studies didn't show a significant effect. But when combined, the overall data clearly proved that aspirin works. This shows how small, uncertain signals become meaningful when analyzed together. The same idea applies to psi research. Individual experiments might seem inconsistent, but when combined through meta-analysis, the overall effect becomes statistically significant. Criticisms and answers. Critics say meta-analysis mixes apples and oranges. But if the goal is to understand fruit, blending apples and oranges is not a problem. It reveals what they share in common. Another issue is the file drawer problem, meaning unpublished negative studies. Meta-analysis can estimate its impact and still show whether an effect is genuine. Hard science versus soft science. We often assume physics and chemistry are far more consistent than psychology, but meta-analyses reveal something surprising. Even particle physics has inconsistent results, and up to 45% of data points get thrown out as outliers. When psi research is held to the same standards, its consistency is comparable to that of the hardest sciences. Final thought. The chapter ends with a poetic idea. If psi phenomena keep showing up again and again across decades of experiments, maybe they're not dreams or coincidences. Maybe they're real, and maybe science should pay attention. Auro. Thanks for watching. If you found this breakdown helpful, don't forget to like, subscribe, and share to support the channel. Comment below which chapter or book you want me to cover next. See you in the next video, with more insights, more summaries, and more knowledge made simple.